The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's Tech Talk on Scope EBCx using whole building interval data. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all phone lines will be muted. This will minimize any background noise or feedback that could distract from the presentation. When you first joined, the attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with the arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use the control panel to submit questions. And gathering your questions throughout the presentation, and Ryan will answer along as the presentation goes. If your question is related to a particular slide, you could also put that number on the slide as well. A PDF of this presentation will be sent electronically to all of you who are registered for today's Tech Talk. We will also be recording it, and it will be available on our website under the resource section. Today's presenter is Ryan Stroop. For the past 23 years, Ryan has been the Building Performance Coordinator at the PG&E Pacific Energy Center. He teaches classes and consults with building professionals on a variety of issues, including building commissioning, energy audits, tool applications, and architectural design. At the center, Ryan has taught over 25 different classes on building measurement, energy efficient design, including a 7 series on conducting energy audits for commercial buildings and a year-long intensive series on commissioning existing buildings. He has taught for Southern California Edison, San Diego Gas and Electric, U.S. Army, Marriott International, and a number of other companies. Ryan is a regular speaker at the BCA annual conference, and he is currently a member of the BCA's California chapter. So Ryan, I will let you get started.
Great. Thank you, Sherry. Hello, folks. I'd like someone just to type into the question interface that you're hearing me okay. To sort of, I'm going to use that as a way of interacting with all of you. So it'd be great if somebody could just type in, yes, we hear you. Great. Thank you so much. I can see the responses, and that's a comfort. So what I've done for this presentation, and I've set up some polls. Now, there's a thing here that says email me for class instructions. This is kind of a boilerplate. I do a lot of teaching, as Sherry noted. But what I'd like you to do, if you could go to that URL where it says time for a poll. What I'd like to do is a few warm-up questions related to this topic, which is basically using interval data in the existing building commissioning process. So I'm going to go there as well, and you'll see the you will see that same URL at the top of the page. So if you can either write down as simple as pollev.com/Ryan Stroop, that's my name, 526. If you go there, I'm going to actually do a few sort of warm-up questions before I dive into the presentation, all related to the topic. So you'll see me just sort of navigate to the polls here. And maybe Sherry, you can tell me when you see the polls on the screen. It's
I see the polls.
All right. So I'm gonna hide your responses here. So the first question, and again, the poll link is at the top of the screen if you'd like to go to this page. The first question asks, this is all related to this topic, dealing with data as part of a commissioning process. So the question asks, what should first be done with monthly utility billing data before the data is analyzed and graphed? And you've got 5 options there. And so far, just one person responding. So go ahead and choose the option you think is the appropriate response here. What should be done first with monthly utility billing data before the data is analyzed and graphed? And I'm going to give folks, I know you all, why not use the poll function and go to webinar? Because my questions are too long, Hassan, sorry. Sherry and I discovered this today. I wrote these and then we realized that my questions are too lengthy for the GoToWebinar interface. So I've got, there's 62 of you. My rule of thumb is to wait until I get half the people responding, but because you're all just navigating this, and again, the link to this poll is at the top of the screen there. Maybe we got 22 people responding to this, 23 now. I'm going to show your responses, and then we can hopefully get more responses as we go. So 52% of you said normalize the data by dividing the usage per bill by the number of days per bill, and that is actually my intended correct answer for this. So nice job. One of the things I really appreciate about these polls, you can change your answer, and you can be either disagree with my correct answer, or you can join the others who selected that answer. So we'll talk about this a little bit. This is addressing the fact that billing data doesn't always have the same number of days in each bill, and so that has to be corrected before you create a chart. And we'll look at some examples of this in a minute. All right, next question. Again, I'm going to hide your answers so you don't have a chance to see each other's answers. This question asks, when creating data-to-data scatter plots, which variable should be plotted along the horizontal x-axis? Oh, so John, Coco, if you would just go to the URL that's shown at the top of the screen, pollev.com/RyanStroop526. You can participate in the polls along with the 20 some odd other people that are doing it that way. So we'd love for you to join us that way by going to. I'm going to give you 10 more seconds on this one. All right. Yep, we're now up to 29. I was hoping to say 30. We got 29 responses for this. So 64% of you said the independent variable, which again is the correct answer. We'd always want to put the rule of thumb for XY scatter plots is to put the independent variable along the horizontal axis and the dependent variable, the thing that's being influenced by the independent variable, along the vertical axis. And we'll look at this in a minute. Very good. Let's do the next. If outdoor air temperature data is not available from a facility's energy management system for energy usage studies, where can data easily be found and accessed for the location? So you've got, again, 5 choices. Let's say you have a building, you don't have trended outside air temperature data. What do? What's the solution? And we've got 24 responses. People are quick on this one. So I think we'll get up to, we're over 30 with 62 attendees. That's awesome. All right. 3, 2, 1. Let's see what you had to say on this. Oh, wow. 86% of you, clearly the majority, picked get the data from NOAA or other meteorological web sources for the closest weather station to the building site. Again, that's the correct response. But it's, you know, as far as sort of my approach to this goes, there's free web weather sources, meteorological sources out there. NOAA does a nice job of packaging this data for this kind of analysis. And I'll show you a couple websites where you can get data for this kind of study as part of my presentation. All right, next question. Oh, so this is, this should not be, you should not be seeing responses. So let me clear those. Hide. Sorry about that. Okay. Which one of the following chart types do you prefer to use to visualize a year's? This is actually more of a subjective question. So it's actually fine. You saw the previous answers. Which one of the following chart types do you prefer to use to visualize a year's worth of whole building interval data? So what's your preference if you had to choose one? And again, this is subjective. There's no right answer to this one. And we're up to 21 responses. And while they're answering, Sherry, this is being recorded, so this is going to be made available after as well. Is that correct?
That is correct.
Great. So let's do 3, 2, 1. Get your answer in, and let's see what everybody had to say on this one. So, as I expected, all of these got some votes. There's not a clear majority. So a lot of people, this is the most popular choices was a time graph of the full year with different fuels on different axes, different vertical axes, and then a scatter plot of outside air temperature versus energy use, which is actually the one that's most popular here is my preferred approach as well, which you'll see in just a minute. One more of these, and then we'll get back to the presentation. So question asks, what is the adjusted baseline energy use for a facility? So what's adjusted baseline energy use? One of those 5 options is aligned with that term. I guess I also realize, Sherry, I don't have my camera going, but I'll turn that on. There I am. And we're at 22, so 10 seconds on this one. Question asks, what is adjusted baseline energy use? So 3, 2, 1, let's see what people said about this. So that's interesting. We got a fair number of votes for the energy use for the period of time before the building commissioning or other energy efficiency measures have been applied. And then we had a fair number of responses for the last option, the calculated energy use for a facility for the period after an implementation project that is based on pre-retrofit usage patterns and corrected for variations in weather or occupancy. Everybody start changing your answers. It's E, it's adjusted. So you're looking and calculating based on the pre-retrofit usage, but it's corrected. That's why it's called adjusted baseline. It's corrected to reflect how the building would use energy for the post-retrofit period, but it's not actually the usage for the pre-retrofit. It's the post-period adjusted to be modeled after the baseline. If that makes sense. So great. That kind of sets the stage for what I want to talk about here. So I'm going to jump out of this and go to my slides again. And Sherry, just verify for me if you don't mind that they're seeing full screen slides, I guess with my camera active. Is that right?
We just see your time for full, but yes.
Yeah, okay.
Yeah.
So very good. All right. So, and they're seeing me. Is my camera still working?
Yes.
Yeah. Okay.
Yeah.
So great. So let's look at a couple examples. This is the traditional way of analyzing usage data. And what you're looking at in a second here is a year's worth of billing data for a high school in San Francisco. So what is your perception of this school? What kinds of questions or takeaways? And just go ahead and type these into the interface, folks. What observations can we make about this high school in San Francisco based on this data? Anything is fair game. Now this is billing data, so this is not what we're really sort of leading to. I'm just kind of addressing the analysis that was available to us before interval data became so prevalent. And this was obviously still useful in many ways. So any observations at all about this high school in San Francisco which, by the way, is where I'm based professionally. That's where my office is located. So not at this high school, but in San Francisco. Any observations at all? Significant drop in energy usage during late January. Okay, so yeah, we've got winter break that's fairly visible there. That's true. Anything else? There's a big takeaway. It's relatively flat, so not a lot of seasonal variation. There's some weather dependency. So peak load in December, January, which is counterintuitive. Adeep, that's true. That's actually a bit odd, right? For a school to be using more energy. Maybe they brought in electric heaters, so that would be something to follow up on. But I like what Derek Chung and there's another Bethany Beers say that there's a energy usage in the summer, and that base in the summer is still pretty high. So why is it so high? I think that's the biggest sort of takeaway question from this. And by the way, this is that normalized utility billing data. We've divided the usage per bill by the number of days per bill. And so the big takeaway here for the school, I think the number one question we would ask as energy analysts and commissioning providers is, why is that summer energy use as high as it is for a school that is potentially, out of session and the building's unoccupied? Of course, we want to clarify all of that. So I'm going to keep going here. We're moving to the interval data analysis. So this is gas data, same thing. It's taking the monthly billing data, dividing it by the number of days per bill. And here you're seeing pretty high base use, which either means they're doing space heating year round, or there's a significant amount of water heating energy use. There's increased energy use in the winter months, which we'd associate with therm or natural gas usage. But we now have a much more sophisticated way of looking at this data. So here's our first interval data chart. I know we've got, I can tell we have a lot of expertise on the line here. So again, I want you to make some observations about this data. This is 1 year's worth of data for a facility in the Bay Area in California. So what observations can we make? I think there are really 3 significant observations that can be made about this facility. We call it, it's interval energy climate data scatter plot number 1. So just type in anything that you see or observations you'd like to make about this facility. And again, I think there are 3 really significant observations. Most of the energy use is between 55 and 75 degrees. Michael Cuck says that's true. So you kind of get the range of the climate, and there's some extremes there, but you can get a general sense of the climate for this location. Kilowatt hour use is higher than expected. There's a correlation between outside. So Lance says there's a correlation with outside air temperature, which is one of the 3 observations. There is a significant variation in magnitude of consumption, regardless of outside air temperature. So I think what I'm getting there from NDEEP is there's a high base load. And what I'm not seeing is anybody talking about the 3rd observation, which is really hard to make, actually. So let's just say that I'll recap the 2. Energy goes up as outside air temperature increases, and we have a high base load. If you can see the mouse on the screen here, the energy use is always about half of the peak, which is pretty significant. But the 3rd observation I'm going to hold on. Let's go to the next example of this. So this is a different facility. And we can make those same other 2 observations, increase energy use as it gets warmer and a high base load, but now we have something different. So what is the difference here? What's the difference in the 2nd facility? What's the significant difference in the graphic representation? Still a year's worth of data, similar climate. What's different? Anybody? What do you see different in this chart? Well, I'm waiting for someone to say it. There's a second cloud, right? There's that little massive data around 400 kilowatt hours. What does that represent? What does that little second cloud mean? Everybody see what I'm talking about? This phenomena here. What does that represent? I'm not getting any responses. Oh, maybe I'm just not scrolled down enough. Yeah, sorry. So people are saying it. It's the night load. And the other facility is, I just wasn't keeping up with all the abundance of your responses. Sorry about that. So you're right. I think I saw Nate comment on the previous chart, which is a data center that never shuts down. And this is a scheduled facility. And we can see the second cloud is the energy use, which is independent of temperature. That's the energy use when the facility is basically unoccupied. So those two clouds are pretty significant in the analysis here. So I'm going to do the next one of these. Again, keep your comments coming. Sorry, just went too fast there. So now this is a kind of illustrating the contrast with this data as it is filtered. This is a school in San Jose now. And you have all the data on the left, and then weekend-only data on the right. So what can we say about this school? A couple things, in addition to the couple unique things, knowing that how the data looks on weekends only. So I should ask, how well does this school shut down on the weekends? Pretty good, or is it pretty lousy? Building is shutting down on the weekends. Yeah, Beth is right. Beth Robin-Weller says clearly shutting down on the weekends. This is a building that's got an Energy Star score up in the 90s. They have things scheduled very well. High usage on the weekends. I don't agree with that, Michael. The usage is quite low. There is some usage, but compared to the way the building uses energy throughout the year, the usage is actually pretty low. You know, you're not seeing a high base load here, so they shut things down pretty well, actually. Weekend load should be only outdoor lighting, but maybe, Kevin, they have refrigeration, right? It's a school. They could have kitchens during that time. So what other observations can we make? What's the mechanical system for this building, for this school? Anybody? Anybody think they can tell the mechanical system by looking at this chart? Electric heating and cooling, Mandeep again, but be specific. Electric heating and cooling, yes, but be specific. There's heat pumps. Yes, it's heat pumps. So this school has heat pumps, and we can tell by that pattern of the electric use going up. There's sort of a minimum usage here where the building basically hits its balance point and it increases as it gets hotter. So great. So I'm going to keep going. It's in the spirit of sort of keeping time flowing here. This is another building. I'll just tell you the story on this. So this was a facility that I evaluated, and I did this analysis before I went to the site. What you're looking at on the left is the site at 2 meters. So you're looking at the total meter energy use on the left, and then the weekday evening energy use on the right. And you'd expect it to be more like that San Jose school, with things shutting down at night when the facility is not in use. But in this case, what you're seeing is these sort of clouds where things are being overridden, set points are being exceeded, systems are still running, even though it's the off hours, it's after hours. And so I looked at this data before I did my site visit, and I concluded that there's a likelihood that this facility has some zones without setbacks and some zones that are not scheduled. So I went and met with the facility staff, and I shared that observation with them, that I suspected that some zones didn't have setbacks and some zones weren't scheduled. And they told me that I was being silly, and that of course everything was scheduled and everything had setbacks. And of course I looked at the control system, and some of the zones didn't have schedules and some of the zones didn't have setbacks. And the point here is I knew it before the facility staff. Things have been overridden and ignored or neglected. And so this is a really important part of that scoping process which is sort of the topic for today, is to do this before you do your site visits and you can get a sense of how the building is operating. And we're going to do an exercise in a little bit. In fact, we're going to do it right now. So I'm going to bring up a spreadsheet where I've already put the data in for a facility. And so let me bring it over here. This is a scatter plot in Excel, and the data is here. There's a column for the temperature data, which I got from a meteorological site. And there's KW data, which I got from the customer or utility. And I put in a couple additional columns here. I put in a column for hour of the day, and I put in another column, which is a simple Excel function. And then I put in another column for day of the week. Oh, sorry. My computer was forcing me to take an ergonomic break. So you've got a column for power, you got a column for temperature, and then I created a column for hour of the day and day of the week. I also put a column in here for a month, and then I can run filters. So what I want to show you, this is all the data for a single year. If I filter this data, a function many of you, of course, are familiar with, I've set the filters up already. So watch what happens to that data when I just choose the weekends. So I'm going to choose Sunday and Saturday and go back to my chart, and that upper cloud drops away completely. So what can I conclude? This building is scheduled off on the weekends, very clearly, based on that filter. I'll go back to my data, and I'm going to bring back the weekdays, eliminate the weekends, and I'm going to start running a filter for the hours of the day. Okay, so my chart just got updated to reflect now the weekdays, not the weekends. And I'm going to go in here and I'm going to start eliminating what I think are the scheduled hours. So I'm going to assume that this building starts running at 7 a.m. and goes until 7 p.m. So I'm just unchecking those in the filter in Excel. All right, we're till 5 p.m. and let's see what happens with 7 p.m. So I go back to my chart, and a huge portion of that upper cloud is gone, but there's still a substantial amount of it. So clearly I don't have the schedule. Either things are being overridden or I don't know the schedule, or I haven't sort of reflected the schedule in the filters. So I'm going to go back here and I'm going to continue to eliminate hours towards the end of the day. It's not letting me get through them all. Excel is struggling. So I'm just going to cut to the chase here. This is a university facility. So in order to get the additional days removed, I had to include the night classes. And what happens when I run this until 11 o'clock at night, that portion of the cloud drops away. And so you can use this process I'm describing as a way of running a filter and eliminating. I'm going to try one more time here. Yeah, there we go. So I just needed to remove these 3 hours. And then I say, I think the 6 a.m. is also when things are running. I eliminate those additional hours, go back to my chart, and I'm back to that lower part of the cloud. So you can use this process to actually determine the schedule of the operating schedule of the facility. So that's my quick filtering example. I'm going to go back to my slides, and we'll continue from here. So another thing that we can do is filter the data and then run regressions and the formula or the trend line calculation for subsets of the data. So this is actually gas use for a facility. Let me answer Bethany's question here. I got a few questions. Oh, thanks, Scott. I guess I'm just moving too fast. You're right. So Mandeep says, Ryan, you're, oh, okay, same thing. Okay. Bethany says, from the utility or the BAS, did you get hourly energy use from the utility or from the BAS? I work for utility, so my tendency, and PG&E has installed smart meters across our facility at most buildings. So my tendency is to get it through the utility. But if it's trended, the power of the trend data is it might even be on a subset or a particular system like the chilled water plant. And you can do the same analysis on subsets of your overall building energy use. All right, so what observations can we make about this facility? We're looking at natural gas data. What observations can we make about this building? Some similar thing. Oh, by the way, this is daily data. We're only seeing data for once per day. Other than the fact we got a really tight sort of correlation. We know when the building is space heating at 65 degrees and below. It is weather dependent. That's true. What's the schedule? What's the schedule of this facility based on this scatter plot? Yeah, 7 days a week. Lance is right. If we were shut off on the weekends, the gas use wouldn't go up with the heating load. It would be, there'd be a cloud down here at the bottom when the building is off, and we don't see that. And so this is a 7 days per week operation. Excellent. So let me continue. This is the website. I was going to go through the process of retrieving climate data, but I've given you two weather station URLs where you can retrieve data. They're free. The only problem I've ever had getting data from these weather sites is when there's been a government shutdown, and the federal government, when it's not staffed, these resources are shut down as well. Otherwise, they're free, they're great. You can choose weather stations by their time period and location. And again, I would encourage you to check those out. I think just in the spirit of time, I'm gonna keep going. I was again gonna make a climate data request. And the next few slides are just about visualization techniques. So this is another chart that I like to make. It's a day of the week chart. And so I've taken the data that I showed you previously, and I created a column or columns in Excel that are day flags for each day of the week. And then I did a pivot table to create these average days per week. This is, if you're familiar with ECAM, energy charting and metrics, it generates day of the week charts, but you can also do this on your own, which is how I did this chart in Excel. And you're looking at the work days, and then the Saturday usage is a little lower than the rest of the work week, but higher than Sundays, and Sundays down here at the bottom. So you can see how little energy the building can use over the course of a typical week. Sundays is kind of a reference for that. Now, why it drops down at 8 a.m. Every day, something shuts down, and actually might be like exterior lights might be the thing that's dropping out, which even turns off on. Now, why does it turn off and then there's something that immediately comes back on? I'm not sure, but so that's an odd anomaly. But what other observations can we make about this chart? Looking at, it's called a day of the week chart, so it's an average representation of each day of the week. Can we tell when the building shuts down at the end of the day? Is that pretty clear for this facility? When? I'll just turn that into a question. At what time does this building shut down at the end of the day? Yeah, 6 p.m. it actually starts shutting down at 5, and then a huge drop. It's very clearly, when you see this kind of precipitous drop in the data like this, that's a very clear sort of things are turning off. Lights and mechanical probably all are scheduled off at the same time. What about turning on? When, yeah, so you're right. There's a half day schedule on the Saturday. Let's see. Jason, I'm going to say your last name right, probably Babocchio, has observed there's a part day schedule on Saturdays. But the startup is really early. Things are starting to come on. There's this starting to ramp up at 2 o'clock in the morning. I know Hassan says 4, but we're starting to see it sort of comes off the flat line here. and starts kicking up at 2, which is crazy early. And then we get this drop, which again might be exterior lighting turning off. But that's the biggest issue here, is why is the warm up every day of the week so long? And it's true. We can also observe, as Michael's noted, that the base load is about 25% of the peak. You know, that may be systems, servers, refrigeration, emergency lighting, other computer loads that can't turn off. But good observations. This is another representation technique. This is a heat map of a typical week, and you know, a heat map is a table where the data is shaded, or the fill process highlights, in this case, the variation in energies. And this is actually the same site where things shut down. It's the school site, I should say. It's the same site we looked at with the data-to-data scatter plot, and you can see things clearly shut down at 11 o'clock at night. Things come on more gradually in the morning, based on this chart, and they're clearly off on the weekends. So you can see how the schedule varies by looking at a heat map. Just a different representation technique. And then, sorry, I've got losing my mouse. There we go. There's a calendar chart, which is a product of eCam, and it's not showing up. Having difficulties today, so I'll just keep going. And again, we're pretty close to the time I think I should be transitioning to taking questions. But the last section is just on energy saving calculations. So I put in here a couple examples. This is pre and post data for a facility after a clear sort of change in operation, and we can take that data and calculate savings. This is energy use for the energy center where I work, pre and post commissioning. This is another example of now using billing data to establish energy savings from commissioning. This is that adjusted baseline. This is from the IPMVP, International Measurement and Verification Procedure, that for option C, that actually would use whole building data to calculate savings. And so this just sort of illustrates that adjusted baseline is the corrected energy use for the post-retrofit period based on the pre-retrofit energy use patterns. So this pattern is not how we would, what we would reference to calculate savings. We'd actually use that pattern of baseline energy use and create an adjusted baseline. And the difference between the post-retrofit and the adjusted baseline, that delta is our energy savings. All right. And this is actually showing you a screen capture from a piece of software that we've developed at my energy center, where we've actually determined the energy savings for a site. It's actually noted up here, 791, 464 kilowatt hours saved per year. And this is the pre-data and the post-data plotted in this chart. And that I was going to spend some time showing you how to take the climate data from a website and process it, but we are pretty much at time. So you know, we did some interaction. So eCam, Michael, is available from the California Commissioning Collaborative, but my understanding, maybe Sherry can comment on this, is those resources are being absorbed by the BCA. So I'm not sure if eCam is going to be available through the BCA, but you could still go to CACX.org and find eCam, or through PNNL, Pacific Northwest National Labs has access to eCam. And you could Google it. It's if eCam doesn't come up, it's energy charting and metrics, and it's free, and you can get it. I thought I had put a link to it in my slides. I think I did. That one slide didn't show the calendar chart. So I wanted to open it up to any questions you have. I should note that if you're interested in the process of taking the data in Excel, I mean, maybe this is something, Sherry, we can do as a follow-up. Today was more of a taste of what one can do with this data, but if you're interested, and maybe this is feedback you could provide to BCA, we could do a training just on the data processing, where we just take a data set and run through the process of doing the VLOOKUP function, so the time for the temperature data and the KW data match up, and then running the filters. If that's of interest, that's something I can certainly do. Sherry, I'll leave that to you and the BCA team, but you got a sense of what the value of this is from an analysis standpoint. So like looking at opportunities, many sort of scheduling control opportunities can be observed. The baseline energy use of the building, which in some cases is unusually high, can be observed. The correlation between weather and energy use can be observed. And so, there's a lot of value to this kind of analysis. So are there any questions about what I shared today that, and I think Sherry has shared the slide deck. I'm not sure, maybe you can comment on that too, Sherry, because I'm happy to make that available to everybody.
Yes, we will be sending out the presentation slides after the Tech Talk, and I do appreciate anybody's feedback, and it looks like you're getting a little bit of feedback on some possible follow-up Tech Talks as well. And if there are
this is something.
Oh, I was going to say we might have a couple questions we have time for a few, and we'll close it up.
Okay. Well, I was just going to say that I do this. I teach my students who are emerging commissioning providers how to do this. This is a standard assignment for them to get billing data and interval data for their facilities and do this analysis. Let me read Mandeep's question here. Do you have suggestions on how to prepare, plan, and present this to facility operators? Many of them may not be as data tech savvy. That's a good question, Mandeep. I think they understand the charts as you walk them through it. And so rather than like show them static charts, my preference is to actually go through the filters in real time with them, so they can see what you're doing as you change the filters for day of the week or hour of the day. And that way they're seeing that. So you're basically interacting with the data. And then you can talk through the observations. And the beauty of doing this with operations staff is they may have ideas about why things are operating the way they are, and that the data represented in charts might trigger them to think about, how things might operate better. So I always prefer to do it in an interactive way, the way I did it today, by actually running the filters rather than doing a bunch of screen captures of the filters. So that would be my preference. And I think different people, you looked at 2, 3 different, I had a fourth, I had a calendar chart with something, for whatever reason, it didn't load. But I showed you 3 different representations of essentially the same data: the scatter plot, the day of the week chart, and the heat map. And some people, prefer one version of the other. So you might actually have all 3 prepared and see which one resonates with that audience. It's not a lot of extra time to do once you've got the data all ready to go, to represent it different ways, and then to see what type of representation resonates with the audience. That would also be my approach. So again, any other questions, please type them in. This is a topic that I feel like has, there's more to it than we can really get into in 30 minutes. It's just like a taste. So Kevin asks, do you know if most utility companies can provide hourly interval data? So I do know that this is something that utilities are transitioning towards, which is, and for a number of reasons, there's a lot of benefits to having interval data available from a sort of a, knowledge is power standpoint. The problem, Kevin, with my expertise is I'm based in California and my work is primarily focused in California. So that might be a really great question for the other attendees today. Do you have access to this data, or is this something that's still not readily available outside of, you know, I know California, New York, and some other states, this is pretty typical, but how readily available is this to most of the others attending today? Anybody use this data? Assuming if they have kW demand meter, I would assume they are also logging kilowatt hours. Yeah, so the interval meter will give you kW or kilowatt hours. That's not you can sort of do either or. And then Laura says this data is rare in Montana. Bethany says it varies pretty widely. Yeah, the timing of the data is for electrical, at least with California smart meters, is 15 minutes or hourly, and then gas data is daily, but you can request it more quickly like hourly. So Lance is saying you typically need to install your own submeter, which is not easy. And so again, if the utilities are already collecting this data, that's the easiest approach. Michael is talking about Massachusetts. ComEd has this data. Beth says at my utility, most larger commercial buildings have interval meters, so it's out there. Mandeep says we find utilities that offer utility rebate programs are more prone to offer the data. Yeah, because they're using it actually with this normalized metered energy consumption. They're actually using it now to calculate incentives, which I sort of had a slide in there about, but we didn't expand on it very much. Some say, yes, I use it, very powerful in North Carolina. Thank you, Paul, for sharing. So, Sherry, I think if there aren't any additional questions, this is a good time to, I think, wrap up, but I'm going to turn it over to Sherry to do any housekeeping.
Yes, thank you. Excuse me, thank you, Ryan. And if anybody does have any further questions, I'm sure you're open to that as a follow-up. But we really appreciate your time and expertise. And on behalf of the BCA, I'd like to thank everyone for participating in today's Tech Talk. And have a great day.
I just was going to say the calendar chart is up there now. I don't know why it didn't load, but that's what it looks like. It's the fourth representation that I intended to show. So thanks, everybody. Sherry.
Thanks, Ryan.